go. Here's what we have now. We also have another set part of this. We have a bunch of other information that come from these graphs that we're going to look into. Part of that is the vertical asymptote. You guys remember that? You guys remember how the vertical asymptote, how do we get the vertical asymptotes? It was h, but why is it h on reciprocal functions? That was the fourth type, essentially. Why is it h on reciprocal functions? It's where the denominator of the fraction equals 0. We've got the same setup with these type of functions as well, where the denominator of the functions equals 0. That's where the vertical asymptotes are. Same concept. What makes the denominator of the fraction undefined? Okay, so right now we're going to go, that's going to eventually be what our graph is going to look like. All right, here we go. First and foremost, what I want you to do is factor it so that we can take a look at what happens on the denominator of the fraction so that we can understand where the vertical asymptotes are. Okay, so go ahead and factor the denominator of the fraction. So that's the fraction factored, the denominator factored. That tells us two things, two pieces of information about the fraction in general. And it tells us two values that the fraction cannot equal. What are the two values that this fraction cannot equal? There's two. Leah? Can't equal 1. Why can't it equal 1? Because of the x plus 1, because of the x or the x minus 1. Makes that denominator of the fraction 0. What else? 1 and negative 1/5. Yes, those are the values that x is not allowed to be because it would make the fraction undefined, which makes the whole problem not work. Make sense? Not 4, because you're okay to have the numerator of a fraction equal to 0. That's okay, because that just makes the whole fraction 0, right? Okay. From that, we're going to go ahead and get these things graphed. On Thursday, we graphed them by first graphing the asymptotes, okay, and then moving from there to the table. We graphed those points. Then we filled in the rest of the information about the graph, correct? So let's figure out the asymptote. Vertical asymptotes. Those are going to occur where the denominator of the fraction is 0, which makes the function undefined. And those two values are the same exact as the domain restrictions, okay, or the values that x is not allowed to be. So our vertical asymptotes are x equals 1. We stated it in a positive fashion because it's a line. X equals 1 is the line, and then the second one is x equals negative 1/5. Now, you have to write them both, and you have to write them both separately because I need you to communicate to me that it's two different lines. Right? Okay, so now what we do is we graph those. We're doing it piece by piece. We're starting with the asymptotes, and then we're moving on to the other parts. We also need to talk about horizontal asymptotes. Now this function, is this function top heavy, balanced, or bottom heavy? This one's bottom heavy. Remember when we say bottom heavy, we're referring to the degree of the numerators and denominators. We're comparing those. The degree of the numerator on this one is 1. The degree of the denominator is 2. That means it's bottom heavy. Okay. If it's bottom heavy, and we're talking about the extremes with horizontal asymptotes, what happens to the ends of the graph, just at the very ends, when x gets really, really large, when x gets really, really positive, goes towards infinity, the denominator of this fraction gets much larger, much faster than the numerator of this fraction, which means the whole entire fraction gets closer to 0 as x gets larger. Okay? At the extremes, when x is really, really large, this gets closer to 0. So our horizontal asymptote is x or y equals 0. So then we're going to graph that. Any questions so far? Max?
How do you get the horizontal asymptote?
You classify it bottom heavy, balanced, or top heavy. And that leads you into either it's y equals 0. It's either the ratio of the leading coefficients, or there's no horizontal, but you could have a slant. There's no slant asymptotes on this, and you know that because it is bottom heavy and it's not going to have a slant asymptote. Second reason why you can know that is when you actually graph it, you're going to see that it's not converging to another line. Okay, we'll see that on example 2. Leah.
When is it going to be a slant?
It's going to be a slant if sorry, blank. It's going to be a slant when it's top heavy. Okay, but there's special characteristics that have to happen on that. Okay. All right, now we're going to start. We go to the table to try to get an idea of what you need. From the table, I want you guys to pick 2 values to the left of each vertical asymptote and 2 values to the right of each vertical asymptote, with the exception of the fact if you're between 2 asymptotes, vertical ones, I want 3 total points there. What I mean by that is I'm going to pick one, say 1, 2, 3, 4, 5, at -5 to get all the way to the left of that. Then I'm going to pick another one, just say -1. I'm going to indicate that here's a vertical asymptote on my graph. Then I'm going to pick 3 in between these 2 asymptotes, and it's got to be between -1/5 and 1. I'm going to pick 0. That's one of them, and it's going to get kind of tight in there. It's not spaced out very much. I'm going to pick 0. I'm going to pick 0.5. I'm going to pick 0.75. It's their value. Okay? Then I'm also going to pick 2 to the right of x equals 1. So then I'm going to pick 2 just for fun, and then I'll pick 6 just to make things interesting. See what happens there. Okay. Here's the deal. Do you guys want to calculate all of these y values by hand or have your calculator do it for you? Right? Because it's safe for me to assume you guys are okay with calculating these if you had to calculate a few of them. You could do that accurately. Can we just decide on that and we're going to go with the calculator? So take out your calculator and try to type in the function as you need to. Now with it typed into your calculator, I'm going to teach you how to use your table in the calculator to calculate the y values automatically. Some of you guys have a table, when you look at it, that has values like -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on, and it's automatically generating those. I personally don't like to use it that way. I like the calculator to ask me what the x values need to be, so then it calculates specifically the y values. Notice how mine are kind of random. What I want you to do is hit second, and then the window button, which is table set, and I want you to make your table set look just like this. After you have your table set that way, a lot of you guys, when you go down to second table, go to second table or second graph, a lot of you guys will not have values typed in for x. It'll probably be blank. If it's not blank, that's okay. Essentially what we're doing now is we can control what x values the calculator is going to put in the table. If we delete it, if you've got stuff in there, you can delete them. Now if you typed your equation in y1, okay, and you type in -5 and hit enter, it's going to calculate exactly what the y value is, as long as you type the equation into your calculator correctly. If you're not typing it in correctly, you've got to work through those issues. You've got to get past that. Okay? So that's what I get for -5, and then keep typing in the rest of them, and then write down your y values. Pull out the points, -5, 1, -1, 2, 3, 4, 5, -0.6, -1, -0.63, and it's going to come and swoop down this way. Okay, nice smooth actually. Should make it smooth. And then 0.4, 0.52, 0.75, 2.74. And it's a loop that comes down here. And it jogs a little bit, goes back up. And then 2, -0.18, and then 6. And it's up above actually, which is an interesting point that we need to talk about. Kind of looks like that. So on the horizontal asymptote is what happens at the ends. That's important. Right now the horizontal asymptote is y equals 0. At the end, at the far right here, it's converging closer and closer to 0 at the very end. But it does hop over the graph, which actually leads us directly into one of the next pieces that we need to talk about. We need to figure out where an x-intercept is on this graph, because in fact there is one. And we know that because the value from here was negative at 2, negative 0.18, and then it went positive for the y at 6.013. Make sense? So it's got to cross the x-axis somewhere. And if it did, and if it crossed it twice when we went to go calculate the x-intercept, we're going to get 2 of them, and that's how we can tell whether it goes up and down twice, okay, or 3 times or 4 times, depending. So right now what we need to do, that leads us right into this x-intercept concept, so we're going to go ahead and talk about that. I'm going to do my scratch work over here, okay, on the side, because there's really not a whole lot of space. You guys can do it in the margin if you want, on the far left. What do we know about an x-intercept? It has to intersect the x-axis, yes. What do we know about y? Okay, you better remember that. Okay, that's to the same degree that you better be able to factor difference in sum of 2 cubes. You better remember that. You also better remember for an x-intercept that y, or a y-intercept x equals 0, which is the converse. Okay, so let's calculate it. So for an x-intercept, y is 0. So we get this statement. We get the statement 0 equals negative. Don't forget that negative out there. 4 minus x. 5x squared minus 4x minus 1. 2 ways to think about it. What makes this fraction 0? What makes the fraction 0? The numerator has to equal 0. Simply stated, right? For a fraction to equal 0, the numerator has to equal 0. You can remember that and just set the numerator of the fraction equal to 0 and solve it. Makes it a little bit simpler. But if you don't recall that, and you want to just get rid of the fact that it is a fraction and multiply both sides by the denominator of that fraction, you're going to see that this whole mess times 0 is still just 0. So you get 0 equals negative. Don't forget that guy. Although it's kind of negligible in this problem because when you divide by -1, 0 divided by -1 is still just 0. But I suppose I just want to distribute it for fun. So you get x equals 4. And that is your x-intercept at 4, 0. Okay? You have a y-intercept. That we got in our table already. So we're not going to spend much time talking about that. That just is where x equals 0. You can put that into the function and evaluate it by hand if you want, or you could use your calculator as well to do it. Okay? Domain, we can hop back to domain. Domain splits in 2 spots, right? So we have to note that. How far left do we go? We go left to negative infinity forever. It splits at -1/5. Okay? But then it goes from -1/5 to 1, and it's going to split there again. And then it goes on forever to the right. The range is done in kind of a similar fashion as well. We'll talk about that tomorrow, though. I didn't want to throw that in there today. It's a little crazy already. Okay. Now, there's one last thing we need to talk about, minimums and maximums. There are one of each. If you remember relative minimums, that means on the graph, how do we get to the peaks and valleys? Maximum is a peak, minimum is a valley. So we need to calculate this one right here, that point, at the very bottom of that. We use our calculator to do that. And you hit the calc button or the second trace, and you use minimum if we're calculating minimum. And we're getting this point right here. And that's where our minimum